Good afternoon, dear students and friends. I again welcome you in the lecture series of the subject EE 145, that is Basics of Electronics and Electrical Engineering. Today we will see the one of the basic theory which is known as the current division in parallel circuit. So after deriving that theory, you can use that equation. So yes, so there is a simple circuit in which there is a DC voltage source, and across the DC voltage source two resistances R1 and R2 are connected in parallel. So when you close the switch, current I will flow through the circuit. At this junction point, principal node A, the current is divided into two parts, that is I1 which will flow through resistance R1 and I2 which will flow through resistance R2. So yes, R1 and as we know, R1 and R2 are connected in parallel, so voltage across both the resistances R1 and R2 will remain same, and it is V volt. Yes, so what is I1 current? I1 current is the supply voltage upon resistance, applies the Ohm's law. It is V upon R1. Similarly, I2 is what? V upon R2. Right. So now let us apply the KCL at node A. So KCL means algebraic summation. It means summation of incoming currents at the junction point would be equal to summation of outgoing currents. So incoming current at the junction point A is I. So outgoing currents are I1 and I2. So I would be equal to I1 plus I2. So I would be equal to I1 is what? V upon R1 plus I2 is what? V upon R2. So take V common, so it is 1 upon R1 plus 1 upon R2. V will be equal to I, and take this on this side, so it would be inverse. So it is 1 upon R1 plus 1 upon R2 inverse. So that is equal to I into R2 plus R1 upon R1 R2 inverse. So take its inverse, so it is V is equal to I R1 R2 upon R1 plus R2, equation number 1. Right, but we had already obtained the equation of I1, that is V upon R1, but I1 is equal to V upon R1, right. So in equation 2, replace V by the equation number 1. In equation number 1, we have obtained the equation of V, right. So replace this V by this V, it means this equation. So I1 would be equal to this I into R1 R2 upon R2 plus R1 into 1 upon R1. So R1 R1 will be cancel out. So ultimately you will obtain I1 is equal to I into R2 upon R1 plus R2. Right. So this equation is known as the current division in the parallel circuit. So what is I1 in the resistance R1? If you know the total current and if you know the resistance R1 and R2, then you can easily determine that current. So I1 current, the current through the resistance R1, that is equal to total current I into R2, means sameno resistance, opposite resistance, it is R2 upon total resistance R1 plus R2 upon R1 plus R2. Similarly, you can obtain the equation of I2, that is equal to I into opposite resistance, that is R1 upon total resistance, that is R1 plus R2. So see, if you don't know the magnitude of this supply voltage, and if you just know this total current, and if you know the magnitude of this resistances, then you can use this equation to determine the branch current through every resistance, right, R1 and R2. Okay, so thank you.